In 1.1, we're going to talk about graphs, and more specifically, we're going to talk about graphing points and graphing equations. I want to begin by talking about the real number line, which is a line where we place the real numbers, counting numbers like integers, 1, 2, 3, 0, negative numbers, -1, -5, -10. There's also 1.5 or square root of a number, square root of 2, square root of 3 or whatever. Those are all the real numbers, and it looks something like this, right? If I wanted to graph or place the number 1/2, it would be somewhere right there. So we're going to use a horizontal one and consider the x-axis, and we're going to use the similar idea with the real number line, but vertical for what we call the y-axis. And there's a 0 or a center point, and anything above it is positive, anything below it is negative. Anything to the right of 0 is positive, anything to the left is going to be negative. And when we combine them together, the vertical and the horizontal axes, we get what we call the rectangular coordinate system, or Cartesian coordinate system. And so here is 0 for both of them, for the x-axis, and 0 for the y-axis, the vertical. And as we can see, it has been kind of broken into 4 sections, or it creates 4 sections, and they're called quadrants. So this would be considered the first quadrant, and we read them counterclockwise. So first, second, third, and fourth quadrant. And where the horizontal axis and the vertical axis meet and equal 0, that's called the origin. Then we want to define order pairs. So order pairs has the following form. It has to be inside parentheses and separated by a comma. An example of that would be the order pair -5, 3, or 3, -5. And as we have here, the first number in the parentheses is the x coordinate, and the second number in the pair is the y coordinate. And here it would be the case if we were to start at the origin at 0, 0 and go to -5, 3, we would start at the origin and go to the left 5 units and then go up 3 units. So this is where -5, 3 is located at, and then the point 3, -5 would be 3 units to the right of the origin and then 5 units down. And so this is a good example that shows us that even though they have the same digits, if we swap the order, we end up in different locations, and that's why it's called an order pair, because order matters. Okay, so x, y, the first number tells us the left and right distance away from 0, and then the second digit tells us the up and down distance away from 0. Now let's talk about graphs of equations. So this right here in the green is an equation, and so a relation between two quantities can be expressed as an equation in two variables. And so we're talking about two quantities. What are they? Well, here's one and here's the other. Those are the two variables. Now, how do we graph this more complex thing? You know, I didn't give you any points or anything to plot, but you could certainly plot this equation. So, before we move on, let's consider what a solution to an equation would be. So, a solution of an equation is an ordered pair where the x-coordinate is substituted in for x and the y-coordinate is substituted in for y in the equation. Now when you plug those numbers in and you do the simplification on either side of the equal sign, you should, or you want to, end up with a true statement. So let's talk about that. Here is an example that we're going to do. Let's consider the same equation. Y is equals to -5 plus x squared, and we want to test out the order pair 3, 4. We want to know, is that order pair a solution to the equation? Well, remember, the order pair goes like this: x, y, and we are given 3, 4 as the point, and the equation is y equals -5 plus x squared. So all we have to do is replace anywhere that we see a y with a 4, anywhere that we see an x with a 3. And so I like to put parentheses around things whenever I plug them in. That kind of gives me an idea of what's being replaced in for x. Okay, so now all we have left to do is simplify. So 4 doesn't change, I'm going to leave it there. -5 and 3 squared is the same thing as 3 times 3, so plus 9. And so 4 is equals to -5 plus 9, which we get a 4, right? And this is a true statement. The left equals the right. 4 is equals to 4, right? That's a true statement. And that's what a true statement is, in case you didn't know. The left side of the equation has to be the same as the right whenever you simplify it, okay? So imagine we put another point. Let's do something just for fun. And let's say, I don't know, the point 1, 2. Is that a solution to this equation? And I don't know, I just made that up. Let's make it negative so that we can input a negative number. So is 1, we're really asking, is the left side equal to the right side? You know, until we show otherwise. So is 1 the same thing as -5 plus -2 squared? It could be. So 1, we're wondering, is 1 equal to -5, and -2 times -2 is +4, and is +1 the same thing as -5 plus 4, which comes out to be -1? And you tell me, is 1 equals to -1? And the answer is no, right? I mean, obviously it's not the same thing. They're two different numbers. So 3, 4 is a solution to that equation. 1, -2 is not a solution to that equation. Now, let's talk about graphing an equation using the point plotting method. So we want to graph this equation, y equals -5 plus x squared, and a technique is to pick some numbers, select some numbers from -3 to 3, and plug them into the equation to see what you get, and convert those pairs of points into points in the graph, and that would be your graph. So let's do that. Here is a table that we're going to use to be organized about this. So here are the numbers of x that we're going to plug in into this equation, and the result, we're going to write it here as an ordered pair. So we'll begin. We have y is equals to -5 plus -3 squared. So we don't know what y is, but we're going to find out in a second. So let me move that here so that we have some room to work. And so y is going to be equal to -5 plus 9, and we get that y is equals to 4, right? So therefore we have the order pair -3, 4. We're going to do the same thing for all of the different points. -2 instead of x, so -5 plus -2 squared is going to be the same thing as y is equals to -5 plus 4, and that comes out to be y equals -1. So we have -2 comma -1. If we plug in a -1 into the equation, we have y equals -5 plus 1, and that gives us y is equals to -4. So -1 comma -4, plug in a 0 in for x, and that would be 0 squared. So 0 times 0 is 0, therefore y is equals to -5. So 0 comma -5. Then we plug in a 1. Okay, so now we have some ordered pairs, and we can create a graph of this equation. And let's see, so we'll start with a couple numbers, left and right. And -3, 4, somewhere right here. That's the first point. -2, -1, right here. -1, -4, and -0, -5, and then +1, -4, 2, -1, and then 3, 4. So maybe you see that we're getting somewhat of a curve, and what we want to do is draw this so that the endpoints go on forever, like those lines right there. And we get something like this, right? Obviously it should be a smooth curve, but we get the idea, right? The graph should look something like this. Okay, and that's how we graph using the point plotting mode, by going through some values of x, plugging them into the equation, and then converting that into an ordered pair. The last thing that we want to talk about is identifying intersects. So what is an intersect? An intersect is when two things meet. In this case, we're talking about the y-axis, the x-axis, or maybe in the future, when two lines meet or intersect. So here we see that there is a 1, and then there's a second intersect, right? This could be a y intersect at, I don't know, maybe point equals to 2. Here it would be an intercept at x equals -2. I don't know the specific number, but you get the idea. There are two different intercepts. On the second graph, there's only one intercept. The graph never touches the y-axis. In this one, the graph only touches the x-axis. And so there's only one intercept, and it happens at x equals some positive number. I don't know, for example, 5. Okay? Here, on the third graph, we have an intercept that's going through the origin, right? So we can say that it goes through y at 0 and x at 0, right? So however you wish to look at it, we can say that 0, 0 is the intercept. Okay? And then on the last example, we see that we have multiple intercepts, and that's fine. There's nothing wrong with that. You just got to be on the lookout for the whole graph. You know, and this is the graph of a circle. And sometimes people will think, oh, here's one intercept, here's the other, and they don't follow through with the whole graph and miss a couple of the intercepts. So be careful and be on the lookout for those so that you catch all of the intercepts. I think that's everything for this video. Thank you for watching.